Imagine trying to pour 10 liters of water through a 1-liter pipe. No matter how hard you try, the pipe has a limit. Communication channels work the same way. No matter how powerful your transmitter or how advanced your receiver is, every communication channel has a maximum amount of information it can carry. This limit is called channel capacity. In the previous lesson, we learned that communication channels introduce errors due to noise, interference, attenuation, and fading. Engineers can reduce these errors using better antennas, improved modulation, and error correction coding. But this raises another important question. If we continue improving the communication system, can we keep increasing the data rate forever? Suppose you double the transmission speed, then double it again. At some point, the receiver begins making too many errors because the channel simply cannot support that much information. This reveals a fundamental fact about communication systems. Every communication channel has a finite information carrying capability. Channel capacity is the maximum data rate at which information can be transmitted through a communication channel with an arbitrarily low probability of error. In simple terms, it represents the theoretical speed limit of the communication channel. Channel capacity depends mainly on two factors: bandwidth, which determines how much frequency spectrum is available; signal-to-noise ratio, SNR, which measures how clearly the receiver can distinguish the signal from noise. More bandwidth allows more information to be transmitted. A higher SNR allows the receiver to detect signals more accurately. Together, these factors determine the maximum achievable communication rate. Intuitively, imagine a highway. A narrow 2-lane road can only support a limited number of cars per hour. Widening the highway increases traffic capacity. Likewise, communication bandwidth determines how much information can flow through a channel. Now imagine driving during heavy fog. Even with a wide highway, drivers must slow down because visibility is poor. In communication systems, noise plays the same role. Even with large bandwidth, excessive noise reduces the amount of information that can be transmitted reliably. Mathematically, communication theory shows that channel capacity increases with both bandwidth and signal-to-noise ratio. However, the relationship is not linear. Doubling transmitter power does not double channel capacity. As engineers continue increasing power, the improvement in capacity becomes progressively smaller. Channel capacity influences every modern communication system. Cellular networks continuously adjust modulation schemes and coding rates to operate as close as possible to the channel capacity. Wi-Fi standards select different transmission modes depending on signal quality. Satellite systems carefully balance bandwidth, power, and coding to maximize data throughput. For RF engineers, channel capacity affects spectrum allocation, antenna design, transmitter power, receiver sensitivity, modulation selection, and network planning. Modern technologies such as LTE, 5G, and Wi-Fi 7 are all designed to approach the theoretical limits established by communication theory. Understanding channel capacity helps engineers answer practical questions such as, how fast can this wireless link transmit? Is more bandwidth or more power the better solution? What is limiting system performance? Channel capacity teaches one of the most important lessons in communication engineering. Every communication system has fundamental physical limits. Better hardware can improve performance, but no design can exceed the theoretical capacity of the communication channel. A common misconception is that faster communication simply requires more transmitter power. In reality, increasing bandwidth, improving receiver design, reducing noise, and using more efficient modulation and coding are often much more effective than increasing power alone. Now that we understand the limits of a single communication channel, we can explore how engineers allow multiple users to share the same channel efficiently. In the next lesson, we will study multiplexing and discover how thousands or even millions of users communicate simultaneously without interfering with one another. In this lesson, we learned that every communication channel has a maximum information carrying capability known as channel capacity. We also saw how bandwidth and signal-to-noise ratio work together to determine the highest reliable data rate a communication system can achieve. In the next lesson, we will explore multiplexing and discover how modern communication systems allow many users to share the same communication channel efficiently. If you found this useful, like the video, subscribe, and follow for the next lesson.